Okay, so for what we're now moving toward in trigonometry for this part of pre-calculus, we are going to need to review what are called special right triangles. Now, if you have never learned about special right triangles, you may want to watch this video a couple times. There's two of them that we're really going to review. Hopefully this is just a review, but these are essential. You will be very confused with much of what we are about to do if you do not understand what we're about to do with these special right triangles. Now, before we review these special right triangles, there's one other thing, an algebraic thing that I want to review with you. It's called rationalizing a denominator. Oftentimes in math, you might wind up with an answer that looks something like this. Let's say that x is equal to 5 over the square root of 7. And now you may want to just key this into your calculator and get a decimal answer, which would technically be correct. In most algebra classes, and this class is a form of algebra class, even though it's pre-calculus, your teacher is not going to want you to give an answer of 5 over the square root of 7. Oftentimes in algebra, we do not like having square roots or radicals of any kind in a denominator of a fraction, because the denominator here, a fraction itself is rational because it's a ratio, but this denominator has an irrational element to it. So what we want to do is it's called rationalizing the denominator. That means getting rid of radicals that are in the denominator. It's a very simple process. What you do is this. So you take your number that you have, 5 over the square root of 7, and then you multiply by the denominator, the square root of 7, over the square root of 7. See, the square root of 7 divided by the square root of 7 is equal to 1. Remember, any number divided by itself is equal to 1. And whenever you multiply by 1, whenever you multiply a value by 1, it still equals the same thing. Like 2 times 1 is 2, 17 times 7, 2 times 1 is 2, 17 times 1 is 17. Right? 17.5 times 1 is 17.5. Anytime you multiply a number by 1, it equals itself. But what we're doing is we're using 1 in another form. 1 has transformed into a different appearance, but it still has a value of 1. So now when we multiply here, 5 times the square root of 7 is 5 square root of 7 divided by the square root of 7 times the square root of 7 is 7, because anytime you do a square root of something times the square root of the same thing, it cancels out the square root. Another way to think about it is the square root of 7 times the square root of 7 is the square root of 49, and the square root of 49 is 7. And therefore, the square root of 7 times the square root of 7 is 7. And so now what we can say is, instead of writing our answer as 5 over the square root of 7, we would write it as 5 square root of 7 over 7. Okay. Now you may see a little pattern in here, and if you do see the pattern, it's accurate. It can be relied upon pretty much every time. Okay. Let's do one more of these, and it's just so that you can get a feel for it. Let's say that we have 2 over the square root of 13. We would multiply that by the square root of 13 over the square root of 13. 2 times the square root of 13 is 2 square root of 13. Over square root of 13 times square root of 13 is 13. Now there is one more thing. Let's do one more, because there's something I want to show you that's going to be relevant to what we're doing. What if I had 8 over the square root of 2, and I'm now going to multiply that by the square root of 2 over the square root of 2, and then 8 times the square root of 2 is 8 square root of 2, and then square root of 2 times square root of 2 is 2. If you're not the radical part, but if the non-radical parts of the numerator and the denominator, if they can be reduced, you need to reduce them. 8 divided by 2 is 4, and therefore this should be written as 4 square root of 2, and then we're done. Okay? That is rationalizing a denominator. Okay? All right, so now there are 2 special right triangles that we're going to understand, and let's start over here at this one. The way that we're going to understand them is based on shapes that we already know. This is a square, okay? Now what's important about a square, there's 2 things you need to remember about a square for what we're about to do. The first one is that a square has 4 equal sides. The second thing is that the square has 4 90-degree angles. So all 4 angles in this square are 90 degrees, and all 4 sides are equal to each other. The other special right triangle, now this is not a triangle, so it's not a special right triangle. Also, this is not the special right triangle we're concerned with. We're going to use this triangle to understand the special right triangle. Because look, this is not a right triangle. Okay, this is actually an equilateral triangle. And what's interesting about an equilateral triangle, just like the square has 4 equal sides and 4 equal angles, an equilateral triangle has 3 equal sides and 3 equal angles. I hope you remember how many degrees are in a triangle. Okay, if you add up all 3 angles of a triangle, you know that equals 180 degrees, right? That's 180 degrees. Now, we just learned about radians. So what you can also say is that if you add up the 3 angles of a triangle, 180 degrees is the same thing as pi radians. So you can also say that all triangles have 3 angles that add up to pi, okay? So if we were to divide each one of these angles by 3, so if we divide 180 by 3, we get 60 degrees. So I can tell you that all 3 of these angles in this equilateral triangle are 60 degrees. 60 degrees, 60 degrees. Now, also you can divide pi. If you were to divide pi by 3, you would get pi over 3. So another way of saying it is that an equilateral triangle has 3 angles, pi over 3, pi over 3, and pi over 3. And if you do the conversion, you'll see that 60 degrees is indeed pi over 3. Okay? All right, so now, what we're going to do, we're going to start over here. Here's what we're going to do. We're going to take the square and we are going to cut it in half diagonally. Okay? So we're going to go up here to this corner right here, and we're going down to this corner right here, and we are going to we're going to draw in a diagonal on this square, and here's what it's going to look like. All right, there's a diagonal, and now what we're going to do is what we need to talk about what that diagonal just created. This diagonal cut the square into 2 triangles. We have a triangle here and we have a triangle here, and they're equal. They're identical triangles. We don't need both of them, so I'm going to get rid of one of them. But I want to remind you that this is a right angle, right? That's from the square, 90-degree angle. I want to remind you that this up here is a 90-degree angle. By the way, this 90 degrees, remember that 90 degrees is equal to pi over 2 radians, right? So we can also say that this angle is a pi over 2 radians angle, okay? This angle up here got cut in half. So a diagonal that's drawn on a square cuts the angles that it goes through. These were 90-degree angles. It cuts them in half. So what we now have is this is a 45-degree angle, and this is a 45-degree angle, okay? We could also say 45 degrees is the same thing as pi over 4. And you can check the work on that, but it is. It's pi over 4 radians. And down here, this one is 45 degrees. And this one is also 45 degrees, or we can say that it's pi over 4. Okay? But now what I'm going to do is, and you're going to hate me for this because you're drawing this in your notebook, I don't need both of them. I only need one of them, so I'm actually going to get rid of this top one right here. And I'm sorry for that. You can just draw a new one. Just leave the square, and under the square, draw another half of a square, which is now what we call, because it has 45 degrees in 2 of the angles and 90 degrees here. Let's confirm, though, it has to be 180 degrees, right? Well, 90 plus 45 plus 45. 45 and 45 is 90. 90 plus 90 is 180, okay? So this is a special right triangle, and it is called a 45-45-90 right triangle, okay? Or a 45-45-90 triangle. Here is the main quality of this 45-45-90 triangle. Because it's half of a square, this is something that we know. We know that this side and this side, because they both come from the square, those sides are equal. They are the same. Okay? Now, because this is a right triangle, I don't know if you recall, the long side in a right triangle is called the hypotenuse. Okay? So here's the hypotenuse across from the right angle. And then the other two sides in a right triangle are called legs. Okay? And in a 45, 45, 90 right triangle, the legs, both of the legs are equal. Okay? And so a lot of times in geometry, what we'll do is we'll put like a couple marks through there and a couple marks through here showing that those two are congruent lengths, or they're the same length. Okay? And that's very important for what we're about to understand. Okay? Now, before we continue with this, so this is a 45, 45, 90 right triangle, okay? We're now going to go over here and I'm going to show you the second of the special right triangles, okay? So we're going to take this equilateral triangle and we're going to do something very similar. We are going to cut it in half, okay? So I'm going to go to the top here to one of these vertices, and I'm going to cut this triangle in half with an altitude. The altitude is going to come down here and make a 90-degree angle. Okay, so I'm going to draw a vertical line here. Now, because it cut this angle in half, this angle used to be 60, right? But we cut it in half, so now it's actually two 30-degree angles. So this one is 30 degrees, and this one is also 30 degrees. We can also say it's pi over 6. And I can prove it's pi over 6. Remember how we just said that pi is all three angles, and then we divided it by 3, so it's each of the angles is pi over 3, but we just cut pi over 3 in half. So if we do 1/2 of pi over 3, pi times 1 is pi, 3 times 2 is 6, there we go, pi over 6. So a 30-degree angle is a pi over 6 angle, okay? All right, now, again, we don't need both of them. Oh, I forgot to draw in here, this created a 90-degree angle, right? It's an altitude, and an altitude always goes perpendicular to the base of the triangle. So we only need half of this one, so we're going to get rid of this half of it. Okay, and this is our second right triangle, and you can see that this right triangle has a 90-degree angle. It also has a 60-degree angle, and it has a 30-degree angle, and so we call this a 30, 60, 90 right triangle. Now, remember how over here I said that this leg and this leg are equal to each other? Well, we don't have that going on over here. We have a hypotenuse, which is opposite the right angle, but this leg and this leg are not equal to each other. In fact, we're not sure what the relationship is between them. But let me show you what we do know. Watch this. If we were to restore what I just erased, right? Here, if we go back to the equilateral triangle, what we do know is that this hypotenuse is equal to this side over here, and it is also equal to this side over here, the complete thing, not just this little one, but from here all the way over to here, all three of those sides are equal because it's an equilateral triangle. But do you remember what I just said we did? When we drew this line in, what did it do? It cut the triangle in half. And that means that down here, where it hit down here, that means that it cut this line over here, this side, it cut it in half. So that means that from here to here, this leg is half of the whole thing. And since the whole thing is equal to the hypotenuse, that means that this smaller leg is half of the hypotenuse. And in every 30, 60, 90 right triangle, the smaller leg, here's what we'll write, smaller leg, or shorter leg, let's say. You rewrite this. The shorter leg, or short leg, is half of the hypotenuse. That is always true. So what's special about the 45, 45, 90 right triangle is that the two legs are equal to each other. What's special about the 30, 60, 90 right triangle is that the short leg is always exactly half of the hypotenuse, and that's important. So you need to remember that for what we're going to do in just a couple minutes. All right, so now what we need to do is, here's why we're doing. You might say, well, why are we trying to understand these special right triangles? We want to understand the relative lengths of the sides of these special right triangles. Now, we already got that this one is equal to this one, but because they always maintain the same shape, they're always 45, 45, 90, or 30, 60, 90, their sides are proportional to each other. Now, the word proportional, I know that's a scary word, especially to people learning math. All the word proportional means is that the lengths all grow in the same fraction of each other. Okay, and I know the word fraction doesn't make you feel any better either, but proportional just means that, for example, if this leg grows by triple, okay, if it grows by triple, let's say that it was 2 and now it's 6, like times 3, right? That means that this leg will also grow by times 3, okay? It will also triple, and the hypotenuse will triple. So proportional just means that whatever one part of it increases by, whatever factor it increases by, whatever factor it's multiplied by, all of the other lengths are also multiplied by that same factor, okay? All right, so here's what we want. Because we want to understand the lengths of the two legs and of the hypotenuse, that's going to bring in a popular formula that most of us remember. There is one very important formula in the world of right triangles that represents the proportional lengths of all three sides, and it's called the Pythagorean Theorem. And if you remember, the Pythagorean Theorem goes a squared plus b squared is equal to c squared, where a and b are the legs and where c is the hypotenuse, okay? And so what we're going to do is we are going to find the proportional lengths of these sides, how they relate to each other. And the way we're going to do it is we are going to just simply assign a length. Well, actually, no. You know what we're going to do is we're going to try and solve these formulas relative to the other distances. You know what? Don't even write down what I just said. Let's just do it. All right, what's happening over here? We have a 45, 45, 90 right triangle. So let's say that this is A, and we'll say that this side is B, and the hypotenuse is C, right? Okay. So, but the two legs are equal to each other. And because they're equal to each other, I can actually now replace B with A. I can actually say that there are two A's. So we can now modify the Pythagorean theorem and say that for a 45, 45, 90 right triangle, that we can say that a squared plus a squared is equal to c squared. And now what is a squared plus a squared? Well, a squared plus a squared is 2a squared, and that is equal to c squared. And now what I'm going to do is this, is I'm going to solve for the hypotenuse, okay? So what I'm going to do here is I'm going to solve for the hypotenuse, and I'm also going to solve for the leg length so that we can get an idea of how the hypotenuse and the leg lengths are related to each other. So to solve for the hypotenuse, all I have to do here is square root the hypotenuse, and I can square root the other side. Now when I square root c squared, I just get c. When I square root 2 times a squared, the square root of 2, that's not a whole number, okay? That's irrational. So I'm just going to leave it as the square root of 2. And then the square root of a squared is just a, okay? And so here's our first formula, okay? Is that the hypotenuse in a 45, 45, 90 right triangle, to find the hypotenuse, all you have to do is take the length of one of the legs and multiply it by the square root of 2. And so now here's the kind of question that I would ask you. I'll give you a 45, 45, 90 right triangle. That's not 45, 45, 90. Let me make a better one. Here we go. Best I can do without a, there we go. So, and what I'll say is, I'll say that this angle up here is pi over 4. Now, because that angle is pi over 4, we know that this other angle over here is also pi over 4 because pi over 4 is 45 degrees. And now let's say that I tell you that the length of this side is 7, okay? And then I ask you, well, what's the length of this side? Well, you'd say, oh, the length of that side is also 7. Why? It's a 45, 45, 90 right triangle. Therefore, the two legs are equal, right? And now if we want to understand what the hypotenuse is, what we can do is take this formula and we can do the square root of 2 times 7. We'll put 7 in for A, and that's going to be equal to C. Now, do not do this in your calculator. All I want you to now write is that C is equal to 7 square root of 2. And now we can just come over here and say that this is 7 square root of 2. And you don't even have to use the formula. All you have to know is that the relationship between the leg of a 45, 45, 90 triangle, its relationship to the hypotenuse is you just multiply square root of 2 times the leg and you automatically get the hypotenuse. So if it's a 45, 45, 90 right triangle whose, let's say that this side is the square root of 8. Square root of 8, right? All we have to do is multiply square root of 8 times the square root of 2 to get this over here. Square root of 8 times square root of 2 is the square root of 16. Oh, by the way, the square root of 16 is equal to 4. So this hypotenuse is equal to 4. So I'm going to sum up. To find the hypotenuse of a 45, 45, 90, all you have to do is multiply the leg times the square root of 2. So the hypotenuse, C, is equal to A times the square root of 2. Okay? All right. Now let's move on to, well, what if I know the hypotenuse and I don't know the leg? Oh, well, you just do the opposite of multiplication here. To go from here to here, you multiply by the square root of 2. To go from here to here, you divide by the square root of 2. And I'm going to prove that to you right now. We're going to go back to this formula here. I'm going to erase this. We're going to go back to this. We know that 2a squared is equal to c squared. Well, if I'm solving for a, I'm going to divide by 2. So I'm going to divide by 2 on both sides and cancel. And so now I have a squared is equal to c squared over 2. Well, to solve for a, I'm going to do the square root of both sides. Over here, that's just going to give me a. And over here, it's going to give me, now this is a little weird, it's going to give me c in the top because the square root of c squared is c. And in the bottom, it's just going to give me the square root of 2. Now, we do not have to rationalize this denominator right now. We would not rationalize the denominator until it was time to identify the value of a. So let's say that we have a 45, 45, 90 right triangle, and let's say that the hypotenuse is equal to 11, right? Okay, and we want to find a. So we would go a is equal to 11 over the square root of 2. Just divide the hypotenuse by the square root of 2. Now we need to rationalize the denominator. And so here we get 11 times 11 square root of 2 over square root of 2 times square root of 2 is 2. And so a now is 11 square root of 2 over 2. Okay? And since this leg is the same length as this leg, it's 11 square root of 2 over 2. Okay? All right. So now let's say that we have another one. Let's say I give you another one. I give them to you in different shapes too. I might give it to you looking like this. Okay? And I'll say, oh, there's a right angle there. This is 45 degrees. This is 45 degrees, right? Okay. So now I may tell you that the distance from here to here is equal to, it's equal to 6, right? And so now I want you to find the lengths of the two legs. Oh, okay, well that's easy. You just divide, you just take the 6 and divide by the square root of 2. Well, now 6 over the square root of 2 is going to, we have to rationalize. We have to do square root of 2 over the square root of 2. And what we wind up with is 6 square root of 2 over 2. But 6 divided by 2 is 3. So really the answer is 3 square root of 2. And so the answer here is 3 square root of 2, and over here is 3 square root of 2. Okay? All right, so that is the 45, 45, 90 right triangle. You're going to be asked questions where I give you the hypotenuse, you tell me the legs, or I give you one of the legs, you tell me the other leg and the hypotenuse. You also have to identify the angles as both degrees and radians. And 45 degrees is always pi over 4. Okay? 90 degrees is always pi over 2, 60 degrees is pi over 3, and 30 degrees is pi over 6. Okay? All right, so let's now come to this one. And let's use the Pythagorean Theorem to try and understand the proportions among the 30, 60, 90 right triangle. Oh, you probably want me to write down the how to convert here, right? Okay. For a 45, 45, 90, to go from, if you're given the leg, hang on, if you know A, to get C, multiply A times the square root of 2. If you want to go, if you know the hypotenuse C and you want to get A, divide C by the square root of 2. That's it. That's our whole formula, our only two formulas for a 45, 45, 90 right triangle. Okay, let's go over here then and try to understand the relationship among the short leg, the long leg, and the hypotenuse in a 30, 60, 90 right triangle. Okay, so let's call the short leg A, the long leg B, and the hypotenuse is C. Okay, well, let's start, the easiest part is C. Okay, C and A. Okay. Remember how I said that C is always twice the length of A, or A is always half of C. So what we can say here is that A, well, let's write it over here. A is always equal to C divided by 2, every time. By the way, C is always equal to 2 times A. So if you know A, you automatically know C. And if you know C, you automatically know A. So those are no big deal. What we really want to understand now is how do we get to B? If we know C or we know A, how are we going to get B? Okay? All right, so to get B, what we're going to do is we are going to replace C with 2A. Because C is always equal to 2A, what we're going to do is we're going to identify the relationship between B and A, because that's one of the easier ones to do, rather than doing the relationship between B and C. Although we could do that as well. Maybe we'll do that after we do the relationship between A and B. All right, so because C is equal to 2A, what we're going to do is we're going to do A squared plus B squared is equal to 2A squared, right? Okay, so A squared plus B squared is equal to, well, 2A squared. To square this, we have to square the 2 and square the A. So 2 squared is 4, and A squared is just A squared. And now we're going to just use algebra. We're going to subtract A squared over here and subtract A squared over here. It's going to cancel A squared, and B squared is now equal to 4A squared minus A squared is 3A squared, right? And now all we have to do is the square root of B squared and the square root of 3A squared. Well, the square root of B squared is B. So B is equal to, remember, we're solving for B here, and we're about to. Here, the square root of 3 is just the square root of 3 times, and the square root of A squared, well, that's A. So what we can say here is that B is basically equal to A times the square root of 3. That's it. That's very simple. B is equal to A times the square root of 3. So if I gave you a 30, 60, 90 right triangle, okay, that's an ugly one. That's not that good. Give you a better one than that. Actually, let me draw it. Hypotenuse here, there, and there. There we go. That's a right triangle. Okay, and you want to, and I tell you that the hypotenuse here is 14. Okay, I tell you the hypotenuse is 14, and I want to know the lengths. Now, let's say I tell you that this angle over here is 60 degrees. You automatically now know that this angle is 30 degrees. But another way of saying this is that 60 degrees is pi over 3, and 30 degrees is pi over 6. That's very important to remember, very important to understand. You must, especially 60, 30, 45, and 90, those are about the most important angle measures, and also 180. All right, so if the hypotenuse is 14, we know that the short leg over here is half the hypotenuse, right? Hypotenuse is 14. So 14 is equal to 2 times a. If we divide by 2 here, or sorry, if we want to know a, we have 14 divided by 2, so that's 7, right? Half of 14 is 7, so the short leg is 7. And we know that the long leg is simply the short leg, 7 times the square root of 3. So the short leg over here is just 7 square root of 3, and we're done. Very simple, right? Okay. All right, well, what if now, given this information, this b is equal to a times the square root of 3, what if I want to solve for, what if I'm given b and I want to find a? All right, well, that's easy. We just divide by the square root of 3 on both sides, right? It'll cancel, and now a is equal to b divided by the square root of 3. A is equal to b divided by the square root of 3, right? And so now, here's something interesting that we can do. We can now use these 4 formulas. We only need 2 of them. If I take a is equal to b divided by the square root of 3 and put it in here, we now have c is equal to, if we want a relationship between c and b, c is equal to 2 times a. And a is b over the square root of 3, right? So that would become 2b divided by the square root of 3. And so now, if we already know b, let's say we're starting with b, so I'm going to get rid of this, and get rid of this, and get rid of this, okay? And let's say I told you that the long leg was equal to, I don't know, is equal to 5. The long leg is 5. And I want to know what the hypotenuse is, and I want to know what the short leg is. Well, there's a couple ways we could do this. To find the short leg, I can just do 5 over the square root of 3, right? Okay, well, 5 over the square root of 3, but I need to rationalize the denominator, so I need to multiply by the square root of 3 over the square root of 3, which will give me 5 square root of 3 over 3. And so that means that the short leg here is 5 square root of 3 over 3. And now to find the hypotenuse, I can do one of 2 things. I can either just double a, and to double a, that means times 2. 5 times 2 is 10. This is going to be 10 square root of 3 over 3. Or I can use this down here. I can put a 5 here for b. 2 times 5 is 10. 10 over the square root of 3. But I have to rationalize the denominator. So I'll have 10 over the square root of 3 times square root of 3 over the square root of 3 gives me 10 square root of 3 over 3, just like I said. So this would be 10 square root of 3 over 3. Okay? All right, so you will be given a bunch of opportunities to be able to identify. I'll try to give you a variety, okay, where I give you this and you give me this and this. You have to be able to determine whether you're looking at a 45-45-90 or whether you're looking at a 30-60-90. And again, I might give it to you instead of telling you it's a 30-60-90. What I might do is give you a triangle and just tell you that this is pi over 3. And then you have to figure out that that's 60 degrees. And then put in pi over 6 up here, which is 30 degrees. And now you know that the hypotenuse is twice the short leg, or the short leg is half the hypotenuse. And that to go from the short leg to the long leg, you multiply by the square root of 3. Or if you already know this, the long leg, then you can divide by the square root of 3 to get the short leg, and then you can double that to get the hypotenuse. Okay? It is very important, in my opinion, for these two, the proportions and relationships. Over here, the main thing is square root of 2. Over here, the main thing is square root of 3. And it's important for you to be able to do these very quickly. That's why I'm going to give you a lot of them. Well, that's it for this particular lesson. Once you understand special right triangles and all the other stuff that we've learned so far, we're just going to learn a couple more things, and then we're going to jump deep into the subject of trigonometry.